So this is the factored form of a quadratic. This question is kind of very tricky, probably one of the more difficult questions. But if you can do one of them, you can do all of them. They all follow like the same little trick that you need to use, okay? So let's look at this question. So he has a music store. He sells a CD for $10 and he can sell about 80 CDs, yeah?
Mm-hmm.
So this is what you call a revenue. Revenue is simply the money that you make. Revenue is equals to cost times the amount. So right now, his revenue, without changing anything, he's charging them $10 each, and he's selling them for $80. Sorry, he's selling 80 of them. So his revenue right now is 800, okay? This is what we have initially. This is the initial case. Now, the change is that he is planning to increase the value of the CDs, okay, by $1. So if it's 10, what's going to be the new price? It'll be 11, yeah?
Mm-hmm.
Say $1 increase in price. So he increases it by 1. So look at this. Look at the trend here. 10 plus 1. And then he loses, how many does he sell now? He sells, it's a drop of about 5 CDs. If he's selling 80 initially, the number goes down by 5. What's the new number?
75.
75, right? I'm going to write it like this, and you'll see why. So this is the new amount. So it's going to be 11 times 75, which is 825. So you see his revenue is going up. That's the goal, to obtain maximum amount of revenue. The question
Mm-hmm.
is, what's the price? What's the new price that he should sell? So right, initially we had $10. Now we have 11, right? And then we can keep going till the price becomes whatever. Now the next set would be, look at this, 10 plus 1 times 2. He's raised the price by $2. That means the number of CDs that he sells is going to be 80 minus 2 times 5. So this becomes 12 times 70. It's 840. You see the numbers going up?
Mm-hmm.
Now you can guess and check your way to the answer because you can only do this, what, 16 times. But that's probably not going to give you the full points. The most important aspect of this question is this. What is our x? What do you think our x is? Something is changing here. Just look at this. Something is changing. Everything else is constant. Something is changing. And I'll give you the third one as well. It's going to look like this. Whatever that is. What's changing here? It's this thing. You see this?
Mm-hmm.
What is this called? So look at this. Let x be, okay, this is probably the most important part. Let x be the amount of price increments. Okay, so that's how many times he raises the price. If he raises it 1 time, it becomes 11. Twice, it becomes 12. But now if you follow this trend, yeah, if x is 1, 2, 3, look at what the equation becomes. And this is, I'm gonna put this in red. Y becomes 10 plus, yeah,
Mm-hmm.
1 times x, because that's the new price. We don't know what it is, but we know the price has gone up by x times. What about for the CDs? What does it become? 80 minus what? Just replace the 1, 2, 3s with x's, right? Just replace these with x's. So it becomes 80 minus x times 5, or it becomes 80 minus 5x. So there you go. That's the equation. Okay? That's the
Mm-hmm.
equation for revenue, where x is the amount of price increments. Now you might see a question where x is price decrease, like he lowers the price. The only thing that's going to change if he lowers the price, that means the price goes down. So instead of 10 plus, it becomes 10 minus. And if he lowers the price, that probably means he sells more CDs. So this becomes 80 plus 5x, okay? So that's
Okay.
the trend. But anyways, in this case, it's gonna be 80 plus 1x times 80 minus 5x. That is our equation in factored form. The question is asking us for the maximum, right? A maximum represents in a quadratic equation. We know this is a degree 2 polynomial because x and x. The whole chapter is degree 2 polynomial. We are looking for the vertex. Given the equation in a factored form, how do we find the vertex? Vertex means h comma k. Remember that? How do you find the vertex? A vertex is simply the midpoint, okay, at least the h value is the midpoint of the x-intercepts. So all you gotta do is find the x-intercepts here. To find the x-intercept, you gotta set y as 0. So your equation is gonna look like this. 0 equals 10 plus 1x or 10 plus x times 80 minus 5x. How do we solve this for x? You're going to set it individually equals to 0. Okay, anytime you see a factored form, as long as you have a 0 on one side of the equation, you have two brackets, you're going to split them up. It's going to look like this. Either you get 0 is equals to 10 plus x, okay? Or you get 80 minus 5x is equals to 0, or 0 equals 80 minus 5x. What is x going to be here? 10
Minus 10.
minus 10, right? Here, what's 80 over 5?
16.
16. Does it make sense for the amount of price increments, right, to be a negative number?
No.
No, because that is strictly a positive. It's like a length, yeah? It's the amount. Amounts cannot be negative. So this one's out, yeah?
Mm-hmm.
So therefore, the new price, remember, this one was price times the amount. That was our equation. 10 plus x is the new price, and 80 minus 5x is the new amount. The question is asking us for at what price. So we're going to look at the 10 plus x thing. So the new price that maximizes the revenue is going to be 10 plus x. We know x is 16, so it's going to be 10 plus 16. It's going to be 26. So $26. If they asked you for how many CDs should he sell, CDs is 80 minus 5x. So the new amount of CDs would be 80 minus 5x, which is 80 minus 5 times 16, which is 20. Okay,
Mm-hmm.
does that make sense?
Uh-huh.
Let's do another one. It's going to be very similar. Actually, that last question was incorrect. Actually, I just figured out something. This question's wrong. Part of it is wrong because we didn't actually answer the question. We wanted to find the vertex, not the x-intercepts. So this answer isn't right. We need to find the vertex. What we found was the x-intercepts. That's not going to help us, right? Because asking us maximize. So x is going to be negative 10. So these are your two x-intercepts, okay? This is the answer. H is going to be the midpoint of the two x-intercepts. So negative 10 plus 16 divided by 2. So 6 divided by 2, h is 3, okay?
Mm-hmm.
So that's actually the answer. 3 price increments. So the new price, it's not going to be 10 plus 16. It's going to be 10 plus 3, which is 13. That's the actual answer. Yeah, because we found the x-intercepts, it's asking us to find the vertex. We should find the h and k. So now the k, you can plug it back into the equation. That's going to give you your revenue. But if they asked you for the amount of CDs, so that's the dollar value, the amount of CDs should be 80 minus 5 times x. So 5 times 3, so 80 minus 15, it should be 65. So that's the actual answer. The last thing we did, we didn't find h comma k, so that wasn't right. This one is, okay?
Mhm.
Let's try doing another one. So once you find the x-intercept, find the vertex, just a couple of extra steps. The exact same question. The only difference is now the price is going down. So this is your initial case. His revenue, okay? Gonna remember revenue is cost times the amount. So his cost initially is $5 and the amount that he sells is 500 packages, okay? That's our initial case. Now look at this, the new case. Again, X is gonna be the same thing as it was in the last question. X is going to be, what was X in the last question?
The price increments.
Yeah, exactly. But now it's gonna be the amount of times the price goes down, okay? That's what X is. Because if the price is going down here, it says
Mhm.
decreases. Or actually, no, it's the same question, isn't it? Increase in price. So it's the same question actually, because uh let's X be, I don't know why I thought it was price decrease. Amount of price increments, because increase of 10 cents. So what's gonna be the new cost if the initial cost was 5? It's going down by 10 cents each time. It'll look like this, right? If it goes down 1 times, it's going to
Mhm.
be 1 times 0.1. On the other side, you have 700 minus. So this should be plus, and the packages are going down by 10. So it should be 10 times 1. So this is the case if he increases the price once. This is the case if he increases the price twice. See that?
Mhm.
What's going to be the equation if he increases the price x times? And all you got to
5
do,
plus x times 0.1.
yeah, exactly. 5 plus 0.1x. And on the other side, you have 700 minus 10x. Okay. See, that's the
Mhm.
important part. Coming up with this equation is a little bit difficult, but now we've seen a couple of questions. Everything is the same. It's the exact same pattern. It's going to be the initial case, plus or minus x, and it's going to be this plus or minus some x. So now that's the answer to part A. Determine an equation for the revenue. So that's the answer to part A. Revenue is cost, the new cost, and the new amount. B, what's the maximum? So now we have an equation of a quadratic in factored form. What's going to be the maximum? How do you find the vertex? Vertex is h comma k.
You find the x-intercepts.
Yeah, you find the x-intercepts. To find the x-intercepts, you're going to individually set the two brackets equals to 0. And it doesn't matter if you get a negative number here because we're not interested in the x-intercepts. We are interested in the vertex. So 0 is equals to 700 minus 10x. Yeah, x cannot be negative, but we're interested in the vertex, which means we have to use both the x-intercepts to find what the vertex is. So you get 0.1x is equals to 5. So x is equals to negative 50 for the first one. And here you get x is equals to 700 divided by 10, x is equals to 70. So those are our two x-intercepts. That's the amount of price increments. This one is a negative number, but it doesn't really make sense, but it's because what the question is asking us is this. You see this?
Mhm.
That makes sense, okay? This one doesn't make sense, but in order to find this, you got to use this information, okay?
Mhm.
So basically what happens if you were to properly graph this is you would ignore the negative quadrants completely. But you see that that vertex, if you just build upon this, it goes to the negative x-axis. So to find this, you're going to use these two numbers. So that's why, even though it doesn't make sense, we have to use it to find an answer that does make sense. So next, we're going to find h. H is the x value of the vertex. It's also the equation of the line of symmetry. How do you find h? We have two x-intercepts.
You add them and then divide by 2.
Yeah, what's 70 minus 50 over 2? So it's 20 over 2, right?
It's 10.
It's 10. So h is 10. So that's the amount of price increments. That's not the new price. That's just the amount of price increments. Now, what's the question asking? It's asking us for, okay, we need to find the maximum daily revenue. So all you got to do is find the k value because the y value of the vertex is the daily revenue, yeah? This question is not asking you for the price, but if it did ask you for the price, the new price, you can also do it individually. The new price will be 5 plus 0.1 times 10. So that's 5 plus 1, that's $6. And the new packages amount will be 700 minus 10 times 10. So 700 minus 100, 600 pounds. So this is your new price. This is your new amount of pounds of packages that you can sell. Therefore, your total revenue, again, remember, it's cost times amount is the formula for revenue. It'll be 600 times 6, which is $3,600. And that's his maximum revenue, okay? That's also if you were to plug this directly into this equation as x's, you'll get 3,600. So that's the k value. So that's the answer to part B. His daily maximum revenue is $3,600. Part C, how many packages of batteries are sold when the revenue is at a maximum? What's the answer to part C? It's one of these numbers. There's 4 options.
The new amount.
Yeah, the new amount, exactly. So last question asked us for the new price. This one's asking us for the new amount. So it's gonna be 600 pounds, okay? Or whatever this is, packages, 600 packages. I don't know why I keep saying pound. But that's the answer to this question. Cool? So this is a general pattern. On a question where the price goes up or down, your revenue will always be your amount plus minus whatever it is times x. And it'll be your amount plus or minus whatever that goes down by times x. So last question, it went down by 10. So this would have been 10. And last question, it went up by 0.1. So this would have been 0.1, okay? That's the general rubric for a question like this. Let's try to one more, a more difficult question. So Martin wants to enclose the backyard of his house on 3 sides. So let's say this is his house, okay? One portion of the house has already been sealed off, okay? What he's trying to do is he's trying to make a fence over here, make a fence over here, and make a fence over here. You see that?
Mm-hmm.
We're interested in these 3 sides. So let's call this W. Let's call this the length. So he needs 2 W's and 1 length. What's the perimeter of the green section? In other words, what's the amount of fencing does he need in terms of L and W?
2W plus L.
Yeah, exactly. What's the area of that rectangle?
L times W.
Right. Cool.
Mm-hmm.
So now look at this. This is the trickiest part. Have they given us the perimeter or have they given us the area? That's why this is a tricky question. You got to look at the units. So fencing costs $15 per meter, okay? And he has $720. What amount of fencing can he buy? If it's $15 per meter and he has 720.
48 meters.
Yeah, 48 meters. Is that perimeter or is that the area? That's gonna be the tricky part. Look at the unit meters. Is that a unit of length or is that a unit of area?
It's length.
It's length, right? So you see that 48? That's your
Mm-hmm.
perimeter, okay? That is your not your area, that is your perimeter. So we're gonna replace the P up there with 48. So you get this equation, 48 is equals to 2W minus L, or plus L, sorry. Let's isolate for either W or L. I'm just gonna subtract 2W from both sides. So 48 minus 2W becomes the length, okay? Like that. And
Mm-hmm.
in this equation, we have two unknowns. That means we need a second equation to work with. We do have a second equation that we can work with. It's the area equation. So your area was L times W, yeah? But now your L has been replaced by 48 minus 2W times W. L times W. Open this bracket. Or actually don't. Do we need to open this bracket? We don't, because it's asking us the large. It's asking us for the maximum, okay? This, you can treat this as your y. A, y, doesn't matter, whatever you name the equation. What form of the quadratic is this in? Is it in standard form, factored form, vertex form? You'll see that it's in the factored form, okay? Because the W there has an invisible bracket around it. So whenever you have two brackets, it is a factored form. Cool?
Mm-hmm.
How do you find the vertex of a factored form? You need to find the two x-intercepts, right? You need to find the two x-intercepts. To find the x-intercepts, just set them equal to 0 individually. So either you have 0 is equals to 48 minus 2W. This will give you W as 24, okay? Or
Mm-hmm.
you get 0 equals to W, which means length is 0, or sorry, width is 0, which is not really practical, right?
Mm-hmm.
Next, that's just our x-intercepts. We need to find the vertex. So your h is gonna be 24 plus 0, yeah? x1 plus x2 divided by 2. So your h is gonna be 12. H in this case is our x value, which is our width. So therefore, when the width is 12, okay, that's our width, your length would be 48 minus 2 times 12, which is 48 minus 24. Your length will be 24. That's when the area is maximized. When the length is 24 meters and the width is 12 meters. Cool.
Mm-hmm.
Whenever they ask you for largest, smallest, maximum, minimum, just remember you need to find the h, okay? You need to find the h. These are just the x-intercepts. That's not our maximum. That's when the curve hits the x-axis. Maximum, you need to find the vertex. So just add them up, divide by 2. That'll give you the x value of the vertex. Plug it back into the equation. That'll give you the y value of the vertex. And that is the end of this question. Let's look at this. It says, state whether the relation is quadratic, justify. Look at A. Is that a quadratic?
Yes.
Why? If it asks you to explain your answer, how could you justify that? There's multiple ways. It's a parabola that opens up, yeah?
Mm-hmm.
Look at the x-intercepts, -1 and 1. They're exactly 1 units away from the vertex. You see that?
Mm-hmm.
It's symmetrical, basically, is what I'm trying to say. The distance from here to here is 1 units. The distance from here to here is 1 units. That means we have the axis of symmetry passing through right in the middle. So it's a symmetrical graph that opens upwards, has x-intercepts, y-intercepts, vertex. That's why it's a parabola or a quadratic. What's the equation of that red dotted line? It's a vertical line.
X equals 0.
Yeah, x equals 0. B, is that a quadratic?
Yes.
Right. Why? Look at this. It's a degree 2 polynomial, right? The degree of
Mm-hmm.
that is 2. That means 2 equals quadratic. Done. C is a little bit tricky. They've given us a table of values now. Do you remember how to find what the relationship is from a table of values? You need to find the differences. Okay, like that. We're not really interested in the x's, we're just interested purely in the y's. So we have 3, 2, 1, 0, 1, 2, right?
Mm-hmm.
I can already tell this is not a quadratic, this is a linear because the differences between all of them, 3 minus 2 is 1, 2 minus 1 is 1, right? 1 minus 0 is a1. Actually, let's see. 0 minus 1 is -1, and 1 minus 2 is -1. So no, it's not a linear, because if it was a linear, then all the differences would have been 1, okay? Or
Mm-hmm.
the first difference, it doesn't have to be 1. The first differences would have been the same if it was a linear. So no, this is not a linear. So we gotta go a level deeper. Let's go to the second differences. 1 minus 1 is a 0. 1 minus 1 is a 0. What's 1 minus -1?
2.
2. -1 minus -1.
-2.
So -1 minus -1, right? So -1 plus 1, 0. Okay.
Mm-hmm.
But anyways, the most important thing here is none of the first differences are the same. Well, not all the first differences are the same. That means it's not linear. Linear is out of the question. And the second differences are not the same either, right? You see this 2?
Mm-hmm.
So this is not a quadratic because the second differences are not the same. And that's the end of this question. Same thing here. To find the first difference, find the second differences. If you get a negative first differences, that means it's opening up. If you get a negative means it's opening down. If you get a positive set of second differences, that means it's opening upwards, okay?
Mm-hmm.
So it depends on the sign of your first or second differences. In this case, it's a quadratic, so if you get a positive opening up, negative opening down. All right, they've given us a quadratic. Which form is this in?
Standard.
Yep. Can we factor this right now? Can we pull anything out? Can we pull anything out in the main equation?
An X.
Yeah. So if you pull out an X, what are you left with? Let's look into that. When I pull out an X, what am I left with?
Negative X plus 6.
Yes. Is this in factored form?
Yes.
Yes, it is, right? Let's go one by one. Equation of the axis of symmetry. They're only asking for H. You need to find the H value, which is the X value of the vertex, right?
Mm-hmm.
So how do you go about finding the X value of the vertex? Fine. If you have a factored form, right? If you have a factored
You
form,
find the X-intercept.
right? Can you tell me straight up what the X-intercepts are?
0 and negative 6.
0 and positive 6, right? See this?
Mm-hmm.
Negative X equals negative 6. Multiply both sides by negative 1. 0 and positive 6. X equals 0 and X equals positive 6. Therefore, the H value is simply the midpoint. 0 plus 6 divided by 2, it's a 3. So therefore, look at this. How do you answer this question? Equation of the axis of symmetry. Remember, it's going to be that dotted line. It needs to be in terms of X equals something. So X equals 3 is the final answer. Okay?
Mm-hmm.
B, find the coordinates of the vertex. They're asking you for H comma K. We already have H. How do you find K?
You plug in 3 into the equation.
Yeah, you can plug in 3 into either the main equation or this equation right here. Doesn't matter. So X is 3, negative X, so negative 3 plus 6. So you have 3 times positive 3, so 9. So therefore, coordinates of the vertex H comma K, right? HK becomes 3 and 9. The y-intercept, you don't even need to do any math. Y-intercept, look at the main equation. It's the c value of the main equation, or the constant, like here. The term without an x on it is the y-intercept.
It's 0.
It's 0, exactly. So y-intercept is 0. And the zeros, we found this is 0 and 6. That's it. It's basically a 20-second question because factoring this is super easy. Now, if there was a constant there, then you'd have to man it. Or worst case scenario, you'd have to use the quadratic formula, which is kind of tricky. Anyways, the question's asking us to graph it. We have everything we need. Not going to be super precise with this. 0 and 6 are the x-intercepts. The y-intercept is also 0. It's opening up, or is it opening up or down?
Down.
Yeah. 3 and 9 is the vertex. Look at this. X-intercept, vertex, x-intercept, y-intercept. Connect the dots. And you're done. Okay? That's it. Easy. Now, the thing about quadratics is that to find the vertex, sometimes it may not have an x-intercept. Doesn't matter. Okay, look at this. How do you find the vertex if there's no x-intercept? The vertex, you see this line?
Mm-hmm.
It's always going to be equidistant from the 2 points that it touches. See that? It's going to be equidistant. In other words, it's always going to be dead center between 2 points that have the same y value. Okay? It's going to be exactly in the middle. Let's say this point is 1, 8. Let's say this point is 3, 8. Okay? They both have the same y values. That means the axis of symmetry, or the x value of the vertex, is going to be dead center between 3 and 1, which is 2. See that? You can't really find the y value, but you can always find h, or you can always find the axis of symmetry by simply finding the midpoint, okay? So if they've given us -3, 8, and 9, 8, what's the midpoint? So -3, 8, 9, 8, right? Your quadratic is gonna go like this. So that's this point, that's this point. We're looking for this equation of the axis of symmetry. Remember, it's gonna be dead center between -3 and 9. Or it's going to be the midpoint between -3 and 9. What's the midpoint? It's the same formula, right? Midpoint formula. Do you remember the midpoint formula? It's just x1 plus x2 over 2, which is also the formula for h. But when we look at h, we so far we've looked at the x-intercepts, but it works for any x values as long as it's symmetrical.
So it's 3.
Yeah, it's just -3 plus 9 divided by 2, 6 divided by 2, the h value is 3. Therefore, the equation of the axis of symmetry, this dotted line is going to be x equals 3, x equals to the x value of the vertex, okay? That's it, easy, right? Nothing complicated, just find the midpoint. As long as it's symmetrical, you can find the midpoint. Probably gonna skip this. It says use a graphing calculator. This is just plugging it into Desmos, yeah? Nothing fancy going on here. We can just skip this. Let's do this one here. Because you probably aren't going to get a question on a test or an assignment. Maybe you have a project or something where you have like 20 different equations. Then yeah, Desmos is good. But if you have one equation, you can use it to double check your answer. But you probably will never be allowed to use that in a assessment scenario, such as an exam or an assignment. Maybe like a summative, possibly, but yeah, anyways. But that's pretty easy, right? You're just typing it into Desmos. It takes like 10 seconds. Let's look at this though. This one, you have to do it by hand, most questions, like most other questions. So we have a ball that's being kicked into the air. Our y value is height, h. Our x value is t, time in seconds. From what height is the ball kicked? What do you think? What are they asking us? So this is a
The y-intercept.
yeah, the y-intercept. What is it?
0.5.
0.5. There we go. That's all. It was kicked from 0.5 meters. That is it. B, when does the ball hit the ground? Now what are they asking us? Now this distance here was 0.5 meters. That's the y-intercept. It has a vertex, we don't know. It has two different x-intercepts. One of them is negative, one of them is positive. What do you think they're asking us in part B?
The positive x-intercept.
Exactly. What form of a quadratic is this in? The main equation H.
Standard.
Yeah. So now we need to find the x-intercept. How do you find the x-intercept of a quadratic in its standard form?
You factor it.
You factor it, right? But this question is very tricky to factor because we're looking for a set of numbers that multiplies to 5 times 0.5, so negative 2.5, and adds up to 15. Probably doesn't exist. So it multiplies to negative 2.5 and adds up to 15. See that?
Mhm.
Nothing comes to mind. What multiplies to 25? 5 and 5? Yeah, no, I can't really think of anything that multiplies to 2.5. That would add up to 15. It's a fraction. One of them is probably a whole number. They're both fractions. So when you see a question like this, okay, there is, unless you can think of the numbers quickly, there's no point trying to guess and check this. We're gonna go ahead and use the quadratic formula. But before we do that, we gotta deduce, does this even have any x-intercepts? Look at the graph. Does it make sense that this one has x-intercepts?
Mhm.
Why? Why must this? It does. Why should this equation must have x-intercepts? Look at the y-intercept and look at the direction of the opening. The y-intercept is positive, yeah, 0.5,
Mhm.
and the graph is opening downwards. The only way that is possible is if the graph crosses the x-axis, right? You have a graph
Mhm.
opening downwards that has a positive y-intercept, so it must cross the x-axis. So it definitely has x-intercepts. So how do you find the x-intercept using the quadratic formula? You're going to compare this equation with the quadratic in its standard form, ax squared plus bx plus c. What is a, what is b, and what is c?
Negative 5, 15, and 0.5.
Yeah, negative 5, 15, and 0.5. So that's your a, b, and c's. Next, you're going to plug it into the quadratic formula, which says this: t or x, whatever your x value is equals to negative b plus minus b squared minus 4ac divided by 2a, okay?
Mhm.
So now it's just a matter of plugging things in there. It looks very weird, but you just plug it in. Negative b, we already know what b is, so negative 15 plus minus square root b squared, so 15 squared, minus 4 times a, so negative 5 is a, times c is 0.5, divided by 2 times negative 5, or 2 times negative a. So I'm going to plug this in. So you get this, negative 15 plus minus 15.3297 over negative 10. So the plus minus means the two different x-intercepts. One of them will be negative 15 plus that number divided by negative 10. The other x-intercept would be negative 15 minus that number, 15 point whatever that is, 3297 divided by negative 10, okay? So negative
Mhm.
15 plus 15.3297 divided by negative 10. So this gives me the negative x-intercept, that is negative 0.03297. Now I'm going to do the same thing with a plus, negative 15 plus 15.3297 divided by negative 10. I just did that. I should have done the minus one. Negative 15 minus 15.3297 divided by negative 10. The other x-intercept is 3.03297. There you go. These are your two different x-intercepts using the quadratic formula. Cool? Are you comfortable with the quadratic formula? If this is given to you, if this equation is given to you, are you able to plug it in? A, B, and C?
Mhm.
It's not that difficult, right? Literally just follow, just replace the letters with the numbers. Once you do a couple of them, it's pretty straightforward. So what's the answer to part B? When does the ball hit the ground? It's something that we just found. How long is, in other words, what's the time? This is the path of the ball, right?
Mhm.
It's gonna hit the ground after 3.03 seconds. This number here, this x-intercept. 3.03 seconds, it's gonna hit the ground. When does the ball reach its maximum height? What are they asking us?
The vertex.
H comma K or just H or just K?
Just H.
Just H, right? Very simple. H is simply the midpoint of the two x-intercepts. So negative 0.03297 plus 3.3297 divided by 2. That's 3 divided by 2. That's 1.5 seconds. So that's your H. D, what's the maximum value of the ball? Now what are they asking us? Maximum height.
To
Remember,
find K.
yeah, to find K, that's it. So you're simply gonna plug 1.5 back into the equation. Well, we don't really have a factored equation, so we have to plug it back in here. So negative 5 times 1.5 squared plus 15 times 1.5 plus 0.5. So negative 5 times 1.5 squared plus 15 times 1.5 plus 0.5. The answer is 11.95 seconds. That's the answer to part D. 11.95 meters. That's the y value of the vertex, that's the k. Now remember, this point here is 1.5 on the x-axis and 11.97 on the y-axis. That's our vertex, right?
Mhm.
It reaches a maximum height of 11.75 meters after it's been in the air for 1.5 seconds. Using that, so wait, let's just do party. What's the height of the ball at 3 seconds? So this is basically asking you, what's the y value when the x value is 3? Very simple, just plug 3 into the equation. For part E, all you gotta do, they want the height when the time is 3, plug 3 back into the equation. So negative 5 times 3 squared plus 15 times 3 plus 0.5. So negative 5 times 3 squared plus 15 times 3 plus 0.5. It's just 0.5. So the height of the ball is 0.5 meters when the time is 3 seconds. Using this information and the fact that our vertex is up here at 1.5 and 11.75, answer this question. Is the ball traveling upwards or downwards at t equals 3? The height is 0.5 meters.
It's going downwards.
Yeah, why? Because it says explain.
Because the vertex, like at the vertex, T is 1.5.
Yeah, exactly. So up until 1.5, the ball is traveling upwards, and then after 1.5 seconds, the ball is traveling downwards, right? T equals 3
Mhm.
means it's beyond the point of vertex, hence it's traveling downwards. Part F, when is the height of the ball 10 meters? What are they asking us here? When,
X is when Y is at 10.
yeah, find the X value when the Y is 10. If you look at the graph, there's going to be two answers to this question because, again, it's a rough sketch, but when the Y value is 10, right? Look at this. It's going to cross the graph twice. See that?
Mm-hmm.
So we're probably expecting two X values in this question. Well, now let's do it. So again, you need to use a quadratic equation here because the numbers are not nice. So you get 10 is equals to negative 5t squared plus 15t plus 0.5. How do we go about finding what t is here? You need to do something in the first step before you can find your A, B's, and C's. Remember quadratic, right? If you're trying to solve it, doesn't matter if it's in your factored form, standard form, one side must be equal to 0, okay? If you're trying to find the x-intercepts, one side must be equal to 0. So what we're going to do is we're going to shift that 10 to the right side, subtract 10 from both sides. So you get 0 is equals to negative 5t squared plus 15t, and you have 0.5 minus 10, you get negative 9.5. You see that? Now, let's use the quadratic formula. Compare this equation with this. Ax squared plus bx plus c. What's your a, b, and c?
It's negative 5, 15, and 9.5.
Yeah, that's it, right? Do you have a calculator on you? I'll give you the equation. I need you to tell me the two x-intercepts. That's the equation, right? So just plug everything in. I'd recommend you doing the square root bit first. Do this first and tell me what you get. Did you get 5 point something? So you'll get this, okay? Root 35 over negative 20. So you first do negative 15 plus root 35. So one of the x-intercepts is 0.45 seconds. When you do the plus bit, and then you're going to do the same thing with the minus. So negative 15 minus root 35 divided by negative 20. The other one is 1.04 seconds. Cool?
Mm-hmm.
So that is the answer to this question, 0.45 and 1.04. 15, let me just double check that. Yeah. And we were expecting two different x-intercepts. The graph is not to scale, but you can imagine how it would look. Make sense? So this is a quadratic, very, very common equation that you can get. This one is like a 10-second answer for each question. Determine the y-intercepts, zeros, equation, yada yada. Look at A, right? What are the zeros? Zeros just means the
negative 5.
yeah, so you have your zeros at -5 and 5. That means your h value is going to be in the middle of this, so it's going to be 0. Cool?
Mm-hmm.
To find the y-intercept, here's a little trick that you can do. To find the y-intercept, you simply multiply the constants. -25. That's it. So this one, x minus 5, so we have -5, 0, +5, 0. Your y-intercept is -25. If you plug your h back into the equation, you'll see that your vertex is at -25. So this is what it'll look like. That's all there is to that. B is also very simple. Your x-intercepts are gonna be 2 and 6, right? You see this?
Mm-hmm.
Just flip them, 2 and 6. That means your h value of the vertex is gonna be 6 plus 2 divided by 2, 8 divided by 2, 4. To find the k value, plug 4 back in there. 4 minus 2, so you get -2 minus 2, so you get 4. 4 comma 4 is your hk. To find the y-intercept, just multiply the constants. And if there's a constant outside, you also have to take that into account. So negative times -6, +6 times -2, -12. And that's all. And that looks like it's opening downwards. So -12, 2 and 6 are x-intercepts, and our vertex is at 4 comma 4, somewhere there. And boom, just like that. That makes sense?
Mm-hmm.
So it's see, once you can do a couple of these, they're all pretty much the same. All right, we're done for the day.
Okay, thank you.
See ya.